Okay, so this video is going to talk about dilations. So in this picture here, the red one is y equals x squared and the blue one is y equals 4x squared. Okay, and your y equals x squared is transformed or mapped to the image of y equals 4x squared. One way of describing this is that it's dilation by a factor of 4 from the x-axis. Okay, so why is it called the x-axis? Well, if I look at this point here, 1, 1, y equals x squared, that point's been transformed to 1, 4. So that y coordinate there has been multiplied by 4. And you'll see it's going away from the x-axis. So that's how you should sort of need to think about it. Going away from the x-axis, it's dilation by a factor of 4 from the x-axis. Or equivalently, a dilation by a factor of 4 parallel to the y-axis. Okay, so some more terminology here. So you'll see here's my y-axis, here's my transformation, and you see that they're parallel. Okay, so a lot of this topic is just understanding the terminology. Alternatively, a different transformation which does the same thing for y equals x squared to y equals 4x squared is, this is y equals squared, this is y equals 4x squared, is a transformation of dilation by a factor of a half from the y-axis. Okay, so what's happening to every single xy coordinate? If you just focus on x is 4, then you would get y as 16 for y equals x squared. And if you put in x is 2, you get the same thing here for y equals 4x squared. So this point here, 416, is mapped to 216. And what's happened is the x coordinate has been halved. So the x coordinate has been halved and it's going towards the y axis. So we call it a dilation by factor of a half from the y axis. Equivalently, again, parallel to the x axis. It's a different way of saying it. So that line there, that transformation is parallel to the x axis. So later we're going to consider a more formal approach for identifying sequences of transformations and finding the equations of the image. You also should note that there are an infinite number of ways of mapping one graph to another graph, unless you have a specific number of transformations that you've said have occurred. So, you know, if you think about it, any xy point, if you're mapping it to x plus 4y, so 4 units to the right, you can do that in many, many different ways. You could go, okay, first I'm going to go 5 to the left, right? And then I'm going to go 9 to the right, and that's going to give me the same image. It's still going to transform 4 units to the right in total. And same with this one, you know, y equals 4x squared, we could dilate by a factor of 2 and then dilate by a factor of 2 again, or something equivalent. So there's more than one way of getting from one graph to the next, unless there's been a specific sort of set of transformations that you need to follow. That's it.